In this quick start video, we will go over all the necessary steps to create a complete drawing of a simple rim fragment. It assumes that you have already calibrated the device and set up the laser scanning for the optimal parameters for the ambient conditions and so on, as shown in the previous videos. So let's begin by starting the LAP control application. First thing you see is this select data source dialog, and on the different tabs you can choose to create different types of databases where our data will be stored. So the default is this memory database, which just stores the data in the memory, which is then wiped once you close the application, so it's just temporary. Then you can also create databases on a PostgreSQL server, which is more advanced technique that we will discuss in later videos. And then you have the so-called file databases, so databases that are stored as a single file plus any photographs as separate files. So there is either the option of the JSON database, or the best or the simplest to use is the Pickle format, which is also the fastest to load and so on. So here we can choose where to create a new database. It's in desktop, the LAP data folder, and let's name it LAP data. So I can type here /LAP_data. That will be the name of the database. I click create. Here on the upper left we immediately see the name of the database and the folder where it has been created. You can click the folder to open it, and you can see here the file has already been created. There is nothing in there yet, it's small, and it automatically has the Pickle extension. Close this now. Okay, so now let's switch to the capture profile mode to capture our profile. You can see everything is already set up. The crop envelopes are set up as we set them before. So let's take a fragment and hold it under the laser line. You can see the profile is immediately being captured. So I can choose the rotation where I can achieve the best possible capturing of the profile, ideally in one go, so I don't have to capture it multiple times. And I can use the pedal to capture it. Now the profile is captured. I can further, if I'm not happy with the smoothing, I can further use the smoothen function here while it's selected to increase the smoothing. Okay. I can also use the paint profile function here to fill any missing parts of the profile, like here the rim hasn't been captured perfectly, so I can just touch it up. I can also use the erase profile function to hide further. Okay, now the next step is orientation. So I click the capture orientation mode and take the profile, take the fragment, turn it around and hold it on its rim, so that the rim touches the glass pane, and this achieves or should achieve the optimal orientation if the fragment is even, if the rim is evenly made, and we can rely on this method of orientation. So I can also, you can see the profile is not captured completely, but that doesn't matter because we just need it to orient the already captured profile. And I can also adjust the crop envelope here to see more of the profile, that part which is touching the glass pane. So we'll get some artifact from the glass pane here, but it doesn't matter right now. I can also use the freeze function here, so I don't have to hold it in place. And now I can left click this profile to select it, use this rotation handle to rotate it, and just left click and drag it to position it, and use the captured profile to achieve the optimal orientation. Okay, unfreeze it here, click capture to return to the profile, and now we see the profile is properly oriented. The next step is to capture the diameter. So let's switch to the capture the diameter mode. So now we rotate the fragment by 90 degrees, and you can see only the upper laser is activated now, and it illuminates the fragment and automatically reconstructs the diameter based on the illuminated arc. So it's important to hold the fragment perpendicular to the profile and select a part of the fragment where it is optimal to capture the diameter. We can do it anywhere on the profile. It doesn't have to be on the rim. So once we are happy with this, we click capture. The arcs are starting to get captured, and we click capture again. Finish. And now we have to select on the profile where the diameter has been captured. And we can select here that it's a rim fragment. It will automatically draw the rim, the right diameter. The diameter in centimeters is indicated here. This is the standard deviation, calculated based on the averaging the multiple arcs that we have captured. Now we can indicate the breaks of the profile, since this is just a rim fragment, using the draw break function. And this green cross is a snapping cursor which automatically snaps to the profile, and here I can indicate by left clicking. I can start drawing the break, just move the cursor to indicate the direction, left click again, and in a similar way left click, move, left click again to draw the break lines, also on the outer profile. Similar fashion. If I right click the mouse, it will disable this function again. I can use this function here, draw inflection line, to indicate some inflections on the profile. Let's say here. So this is already a finished simple drawing, and now we can add a photograph. We do this by switching to the capture photo mode, and we can turn on the lamp. I'll put one of the included paper sheets on the glass pane, either the black or the white one, which will act as a background for our photo. And put the fragment on the paper sheet. Now the first thing here is to adjust the exposure, so we can optimally see the fragment to be photographed. And also it's important to set the focus on the photo camera. In case you are using the Photo Plus lens, there are two possible settings: aperture and focus. To adjust focus, first loosen the lower locking bolt. And then adjust the focus by rotating the lower ring. Afterwards, tighten the locking bolt again. You can adjust the aperture by loosening the upper locking bolt and then rotating the upper ring. The standard aperture number is 4, and it's best to avoid aperture numbers higher than 8 because this degrades image quality. The aperture influences the depth of field. It's also possible to adjust the white balance. This is optimally done by just using the white background and just dial down the exposure a little, and using this auto white balance button, which will adjust the white balance automatically. Let me put the fragment back. Set the exposure, and you can see here there is an automatic cropping going on. If I adjust this threshold here, I can either adjust the upper threshold, which determines what will be captured in the end. In this case, it makes sense to also use a cropping function similar to the profile camera. So I just left click, hold the mouse button and drag over the screen, release, which will create a crop envelope. I can further modify this envelope by right clicking and dragging near the borders. And you can see this green outline is where the photograph will be automatically cut out. It will be masked. In some cases, especially if we are photographing a light object on a darker background, it's useful also to adjust the lower threshold. In this case, the upper threshold is sufficient. So now I just click capture, and the photograph is automatically masked and placed into the drawing. I can just by left clicking and dragging reposition it on the drawing. I can use this rotation handle to rotate it. I can also, in case I want to scale it, normally it scales to approximately the correct size, but it's possible, especially with larger fragments, if they are photographed closer to the camera, that they are captured larger than they should be, or not in the correct scale. I can enable the grid here. This shows a millimeter grid, and I can use the scale function here. If I enable it, this handle now becomes a scaling handle. So you can scale the photograph and place it anywhere on the drawing. Now that our drawing is complete, we should make sure to enter a sample ID or find number, and we can store it just by clicking store here. It will be saved in the database. but the database itself is not automatically saved to the hard drive. So first we have to click save here, or we can just click it after creating, save it after creating several drawings. So I can do it right now. I can also choose to use autosave after every drawing, so automatically after each storing, the whole database is saved to the disk. All our created drawings can be accessed via the browser interface. Open it here, which opens another window with a table containing all the data that's stored. So here is the sample ID. Here is the drawing, the generated reconstruction in SVG format. This is automatically generated every time the drawing is stored. This is the data about the geometry data. Regarding the profile itself, if I copy it here to clipboard, either like this or Ctrl+C, and open a text editor, paste it here, then you can see it's just a series of coordinates in a well-known text or WKT format. So this is a standardized format to store geometry data, and this is then used to recreate the drawing when it's loaded again in the software. There's also information whether this drawing has a rim, bottom, and so on. There's also the radius, which in this case indicates the radius in millimeters at the rim of the drawing. So if I double click this row, I can just double click here on the object ID. It will load again in the LAP software, and I can further manipulate it if necessary. I can, for example, adjust the orientation, to other modifications, add more details, add another photograph, and so on. And I can store it again. It will update the data in the database. Now, if I want to use the drawing outside the LAP software, I can, for example, just simply open it in a vector editing software like Inkscape, which I have opened here. So you just drag and drop this generated file into the software, open it, and then I can manipulate here like just another vector drawing. So it's stored as a vector which can be manipulated, and it's stored in the correct scale. So if I use the measure function here, then you can see the scale. It's 50 millimeters, so it's in correct scale. So there are also other functions which I can use to export the data from the LAP software. Demonstrated, let me open another database with more drawings that I have already prepared. So to open a database, an existing database, just click here on the Connect to Database tool, and let's select it's a Pickle database. Go to the Pickle tab, desktop, to the folder where I have stored the database. Click on it and click Connect. So this has loaded the database now, and via the browser you can see there's more drawings here, and I can use, for example, the Images tab here to see thumbnails, previews of the drawings. I can also open the drawings by double clicking them. sometimes if I have created the drawings with the different settings, we will talk about possible settings of the drawings in another video. I can choose to load these settings so the drawing is rendered according to those original settings, or just choose to ignore it and use the current settings of the software. So this I can open the drawing again, and what I can do here, for example, if I would like to export this data into a spreadsheet, I can simply use the export the data function here. Desktop, save. I can either choose a Excel format or a CSV format, or even an S3 shape file. Click save. It will indicate that it has exported it to this file here. It's on my desktop. You can open it, and you can see here there's the sample IDs. These are the paths on the hard drive to the reconstruction drawings, which are generated every time the drawing is stored. So if we have a look here in the folder, there is now under the database itself there is a subfolder. There's a numbered subfolder. This has number 0, but when there's more than 5,000 drawings, it will be 0001, and then 0002, and so forth. So here are the drawings in SVG format, and whenever a drawing has also a photograph associated with it, the photograph will be stored separately as a JPEG file without the masking. So you could add, for example, a scale bar here or a color chart, which you would mask out in the software. So in the drawing it would be visible, but you would have it stored. And the drawings are always generated using these stored photographs. So here in our spreadsheet there are links to these files. There is also the information about the profile geometry in WKT format, information about the rim, and so on and so on. In a further video we will also see how you can add your own additional information to each drawing, such as context number, feature number, area number, and so on. We can also export the data from this browser interface in form of a PDF catalog. So I can either select some drawings or just use this select function to select all, or if none is selected, then automatically the whole database is exported. So let me just select this 4, export it as a catalog. Here I can either let the software automatically determine the scale, or I can explicitly specify that I want them in a scale 1 to 3, the page size of the catalog, line width of the drawings, where it should be stored. Here it's automatically suggested to store it on the desktop, which is okay. And it has been exported to this file on the desktop. Let me open it, and you can see it's a regular PDF where the drawings are exported in scale. There's a scale bar on every page, and you can further manipulate this easily. It's in vector format to create a catalog according to your needs. You can also export individual drawings, either as rasters or as PDFs, as AutoCAD DXFs, or SVG drawings. Here you can also select the scale, line width, and the destination in this case would be a folder where the individual drawings will be exported. So this concludes our quick overview of the basic drawing functions and how to create drawings. And make sure to have a look also at our other instructional videos where we will discuss all the other many functions of the LAP software in detail.